This video is over topic 31, numbers 7 through 10. So these are all not being asked to write an equation, but a situation that's going to take an exponential calculation. The way you know it's going to take an exponential calculation is because you have a percent and then each per every something that indicates that percent change is being repeated. When we did percent change before, if you were trying to reverse percent change, you had the new and you needed to find the old. You could not do that with just the given percent. You had to do the 100+% increase or 100 minus percent decrease. So reversing percent change, you have to work with that adjusted percent. Same thing here where we are repeating percent change. We have to work with not just the given percentage, but the 1 plus or 1 minus decimal form of the 100% plus, 100% minus. You're going to set up a calculation just like with the exponential function. It's just you're going ahead and plugging in something for x or for t right away. So, person takes 200 milligrams of a drug. The medication is metabolized at a rate of 20% each hour. So again, metabolized, you don't need to know that word. The medication is something at a rate of 20% each hour. That word is the change word. So say changed in some way. If you don't know what that word means, even if you do know what that word means, you still have to think about, is this increasing or decreasing? Think about the context. You take a drug, you take a medication, what happens over time? You have to take more of the medication. It runs out, its effectiveness. Why does it run out? Because your body is processing it and you're ending up with less and less of that substance in your system. So this is going to be a decrease. So we're going to have a minus 20%. It has to be subtracted from something. That would be the 100%, or in decimal form, 1 minus 0.2. And so that gives what we're going to multiply by is the 0.8. So this is the change factor. 200 is the initial value. So 200 times 0.8 to the 4 hours. It says each hour, and it's 4 hours. Make sure those match up. Then it's that 20% decrease is happening 4 times in the 4 hours. So 200 times 0.8 to the 4th power, 81.9. After 8 hours, calculation is just the same, other than it is now an 8 instead of 4. One thing to notice, maybe, like the amount that it decreased in the first 4 hours, it went down by like 120. In the second 4 hours, it went down by only like 50. So that's that slowing down decrease process. So then number 8, there are 35 frogs in a pond. Their population grows 25% every, there's your Q, exponential, every 2 years. Whatever it is every 2 years means that this is our 1 unit of time. So our time unit isn't years, it is 2-year periods. Grows 25%, so we're going to have a plus 0.25. Of course, the 1 on the front there always. 1 plus 0.25, 35 is the initial value. So it's going to be a 35 times 1.25 to what power? So after 8 years, what we want to put here as the power is how many times the 25% happens. And in 8 years, that is 4 times the 2 years. So 4 is our power on this. So a little bit tricky there with the every 2 years instead of every year. You can't just divide it like it's not going to be 12 and a half every year. It's more complicated than that. So you got to just treat that 2 years as the unit. So 35 times 1.25 to the fourth power, 85.44, whatever, rounding to 85 frogs. Don't double round that, you round to 85.45 and then round that to 85.5 and then round by just that first digit after the 85 is less than 5. Then number 9, the half-life of a medication is the time it takes for the amount to be cut in half. If a drug has a half-life of 8 hours, how much is left 24 hours after taking 1,000 milligrams of the medication? Now you might look at this and you can figure out, all right, it starts at 1,000 at time 0. After 8 hours, the half-life means it's cut in half. So 8 hours, half of 1,000, 500. Then another 8 hours. So now at 16 hours, it is half again. So half of the 500 is 250. Then another 8 hours. Now at 24 hours, half again. So each time going half. Half of the 250 is 125. So 3 half-lives there, 3 times of the 8 hours. Not that complicated to just do it one step at a time. If it was for 48 hours or 72 hours or a week, that would start getting pretty tedious counting those halves. So we can also still do this with an exponential initial value of 1,000 for a half-life. This is a 1/2 or a 0.5 is the base here, the change factor. So if you're losing half, then you still have half as well. 1 minus 1/2 is 1/2. And then it's to the power, we saw that it was 3 times. We're taking the 24 divided by 8 is another way to look at that. How many 8s are in 24? So 1,000 times 1/2 to the third power. You could also do it as 1,000 divided by 2 to the third power. So you're thinking I'm divided by 2 3 times. So that divided by 2 is what's being repeated 3 times. Then you could do it that way as well. But 1,000 times 0.5 to the third power. So hopefully at least one of those methods makes sense to you. Then you can ignore the other ones. Then number 10, also here. So an account starts at $8,000 and grows at a rate of 2.5% compounded annually. So it doesn't say per or each, but we have this word compounded annually. What that means is added each year. The compounded means added, annually means each year, once a year. So we could say it grows at a rate of 2.5% per year. It grows, so it's going to be 1 plus 0.025 for the 2.5%, 8,000 initial value, 6 years for the power. So 8,000 times 1.025 to the 6th power, or 8,000 times parentheses 1 plus 0.025 and parentheses to the 6th power, 92, 77, 5473, etc. We'll round this. It doesn't say, so money, though, we'll round to the nearest cent if not otherwise specified. 9,277.55.